This nutshell shows both the state and structure diagrams and the derived C code for the GPIO problems listed. To obtain the most from the nutshell, it is advisable to pause the video when suggested, and try to develop your own state and structure diagrams for each problem before seeing my model solutions. Then use the diagrams to write the C code in the free Microchip Studio. If you find this nutshell useful, please support the channel by liking the video and subscribing. Read the problem for the smoke alarm, then pause the video and write the pseudocode and the state diagram. I have rewritten the problem, then I wrote some pseudocode for the state diagram. There's a state diagram shown here. We have alarm off, alarm on, and test, and we show the transitions that go between these states. Now pause the video and write the C code from the state diagram. We can see the C code here. We have the defined statements for the I/O and for the state constants. We're using the switch with the state alarm off, state test, and state alarm on. We show the outputs for the state and the transitions to move to the other states. I have written the code in Microchip Studio and have downloaded it to the Mega Pro board so we can see the code in action. We can see the LED is flashing every 2 seconds to show the alarm is going. I push the test button. We can then test the alarm to see that it's working. If smoke is detected, the alarm comes on and will stay on until the smoke is gone. Now solve the same problem using a structure diagram. Pause the video and write the pseudocode and the structure diagram. I have rewritten the problem and written some pseudocode, and then I had 2 attempts at the structure diagram. This is my final attempt here. File 1, the alarm's normally off, toggle the LED. If the test button is pressed, the alarm and LED goes on, wait for 2 seconds. And down here, while the smoke sensor is on, the alarm and LED should be on. So now pause the video and write the C code from the structure diagram. This is the C code. We define our inputs and outputs. We set up the GPIO. While 1, normally the alarm is off. I have this delay here so that the computer doesn't get locked up for 2 seconds. It's always going through the countdown. Then we have the if test button and while smoke sensor alarm. I have written the code into Microchip Studio and downloaded it into the Mega Pro board. We can see the board in action. We can see that LED is flashing every 2 seconds. If I push the test button, the buzzer and LED goes on for 2 seconds. If the smoke sensor is active, the alarm is active and LED, and will stay that way until the smoke sensor is inactive. The next problem is the egg timer, where we will get you to write the C code from a state diagram. So pause the video, look at the problem, write the pseudocode and the state diagram. I have looked at the problem. I have rewritten it using the pseudocode and the state diagram. We have 4 states: stopped, start button's pressed, we run the counter, 5 seconds to go, we pulse the beeper, 0 seconds, beeper is on, and we exit these states anytime the stop button is pressed. Now pause the video and try to write the C code from the state diagram. I have written the C code here. We can see our define statements, our state variables. If I scroll down and look at the switch statement, we can see the states, the outputs within the states, and the transitions that will cause the states to change. I have written the C code in Microchip Studio and downloaded it to the Mega Pro board. We can see it in operation. I can start the count and I can stop the count at any time. Starting the count again, we will let it count up for 10 seconds. Then it beeps for 5 seconds. And the beep stays on until we push the stop button. Looking at the same problem, we will write some C code from a structure diagram for the egg timer. So pause the video and look at writing some pseudocode and the structure diagram for this problem. You can see my pseudocode written here. This helps me do the coding here, which helps me make the structure diagram. While 1, if start pressed, we are in while loops. If the stop button is pressed, we will exit the while loop. Otherwise, we will simply count down, toggle the LED for 10 seconds, LED and buzzer for 5 seconds, and buzzer on until the stop button is pressed. So now pause and see if you can write the C code from this structure diagram. I have written the code from the structure diagram. We define our inputs and outputs, and then we have a while 1. If start button is pushed, we set the time, then we decrement until either time is at 0 or the stop button is pressed. We reset the time here and we toggle the LED and the buzzer until the time is finished or stop button is pushed. Then we'll stay here with the buzzer on until the stop button is pushed. I have written the code in Microchip Studio and downloaded it to the Mega Pro board to see it in action. We can see here we push the start button. We are counting, flashing the LED. We can stop at any point. We can start again. The LED will keep on counting up. After 10 seconds, the beeper will toggle. And after 5 seconds, the beeper will stay on until we stop the counter. You are to create a state diagram and write the C code for the electric heater. So read through the problem, pause the video, and rewrite the problem and create the pseudocode and the state diagram. I have rewritten the problem, and then I have created a state diagram. There are 3 states: heater off. When you turn the on switch, the heater is on. If you turn the off switch off, the heater goes off. If the heater is on, tilt is active, then the heater is in the tilt mode, else it goes back to heater on. And you can see the outputs and the transition points here. So pause the video and look at writing the C code for this. So here is the full C code. We've defined the inputs and outputs, the state constants. We're using the switch statement. So we have the heater off, heater on, and heater tilt. We show the outputs and the transition between the states. I have written the code in Microchip Studio and downloaded it to the Mega Pro board so we can see it in action. Currently the elements are off. If I turn the heater on, I have the 3 elements on right now on a high. I can change it back to low or to high. If there's a tilt, then the heater is turned off until the tilt switch is inactive. The heater goes back, and then I can turn the heater off. Repeat the same problem, but in this case we will write C code from a structure diagram. So pause the video, rewrite the problem, and write the pseudocode and the structure diagram. I have rewritten the problem and written some pseudocode that helped me create the structure diagram. A while one loop: if the heater is on, if the tilt is on, all elements are off. If the tilt is off, then if high switch, 2 elements on, else 1 element. And if the heater is switched off, then all elements off. So now pause the video and write the C code for this structure diagram. We can see the C code written from the structure diagram, the defined statements for the inputs and outputs, the while one, and the if-else structures. And finally, I have written the code into Microchip Studio and have downloaded it to the Mega Pro board, and we can see this one running. Currently the heater is off. We can turn the heater on. The elements come on. We can turn high or low. And if there's a tilt happens, then the elements go off until the tilt is inactive and the heater operates as normal.